A-Level Chemistry Paper 2, June 2018, walkthrough. Question 1. Given equation for the combustion of heptane in excess of oxygen, it tells me what heptane is, C7H16, so I'm just adding oxygen, I'm forming CO2 plus H2O water, I just need to balance it. Identify suitable catalyst for the process. Well, it's catalytic cracking, high temperature, slight pressure. If it was thermal cracking, high temperature, high pressure, but because it's catalytic cracking, it tells me high temperature, so the other condition other than high temperature is slight pressure. The catalyst is zeolite catalyst, and the equation for the catalytic cracking, C16H34. Arrow, I know I'm going to form one molecule of heptane, C7H16, one molecule of cyclohexane, C6H12, and the remaining product, ethane, propene, C3H6. Given the equation for the propagation steps in the reaction of butane to form 2-chlorobutane. So first things first, you need to draw out butane and individual, so CH3, CH2, CH2, CH3, plus the chlorine-free radical. And then you need to spot I want to form 2-chlorobutane. So the free radical has got to be on the second carbon. So therefore that's what happens. CH3, CH2, CH dot, CH3, second carbon, plus HCl. And then, same thing here, you just copy and paste it here, but in this case, you're adding excess of chlorine, and then you form your CH3, CH2, CHCl, CH3 plus Cl dot, and you can see the Cl dot is regenerated by the end of the reaction. Then for the radical from this chlorofluorocarbon is responsible for the depletion of ozone atmosphere, Cl dot, not chlorine, Cl dot. That's radical. Cl dot plus O3 are ClO dot plus O2, ClO dot plus O3, 2O2 plus Cl dot. You just need to memorize those two. So already, 2, I guess maybe 3 marks on memorization. The final mark, explain why you can, obviously the aid of equations I've copy and pasted those two. Why? Because the Cl dot is regenerated and causes a chain reaction in the decomposition of ozone. So Cl dot is regenerated and causes a chain reaction in decomposition of ozone. Give that UPAC name for CH3OH, CH, 3CH2Pr. 3-bromo, 2-methyl, propan, -1-ol. Explain what the halogen alkane is attacked by nucleophiles reaction, nucleophilic substitution mechanism. First things first, bromine, I can see Br and carbon. Bromine is more electronegative than carbon. Carbon is partially positive / electron deficient. Lone / electron pair are nucleophile donated to the partially positive carbon. Bromine more electronegative than carbon. Carbon partially positive / electron deficient. Lone / electron pair nucleophile donated partially positive carbon. Draw a plate formula Y, and it tells you the range. So you look in the periodic table at this infrared spectrum, and then you draw a plate formula Y. C10H, CH, C10H, CH3, C4H6O2. Give the structure of compound Z, C3CH, NC, HO, HCN, OH, CH3H. Suggest a reagent for reaction 3, KCN, and dilute acid. Explain in reference to intermolecular forces why distillation allows propanol to be separated from other organic compounds in reaction mixture. So ignore this bit, I look at the focus on the blue part. Well, the first things first is you just need to talk about intermolecular forces, right? Aldehyde, in this case propanol, has dipole-dipole forces between molecules. Propan-1-ol, the alcohol, and the propanolic acid, the alcohol and the carboxylic acid, both have hydrogen bonding between the molecules. So 2 marks just for stating aldehyde has dipole-dipole forces between molecules. Propan-1-ol and propanolic acid have hydrogen bondings between molecules. Then my final mark, I need to say the forces between molecules in aldehyde are weaker than the alcohol and acid, therefore it evaporates first. Give 2 ways of maximizing the yield of propanol obtained by distillation of the reaction mixture. Keep the temperature of the reaction mixture below the boiling point of propan-1-ol of the alcohol, or cool the distillate / collecting vessel. Describe how you carry out a simple test tube reaction to confirm that the sample of propanol obtained by distillation does not contain any propanolic acid. Use sodium carbonate and add it to a sample of the distillate. Effervescence confirms the presence of acid. Calculate value for the enthalpy of combustion of ethanol in this experiment. 3 marks. So first things first, I'm looking at delta H is Q divided by moles. Q equals MC delta T. Moles is mass of MR. I'm copying and pasting those 3 equations, right? Anytime enthalpy of combustion or anything, right? When you know this identifies topic, I'm copying and pasting those 3 equations. Then I'm like, okay, so can I find out Q? Yes, I can. MC delta T, M is mass of water. I've got Q. Can I find out the moles? Yes, the moles of the alcohol, ethanol. Mass of MR, I've got the mass, yes, in milligrams, equivalent to grams, over the MR of ethanol, perfect. Then substituting here, delta H Q divided by moles, but the final step, actually 2 steps left. I want it in kilojoules, so Q, which is usually measured in joules, need divided by 1000, equivalent to kilojoules. Mole stays the same. I get delta H, but then I get it as 953, but I need to add a negative sign because temperature increases. So therefore it tells me X, as temperature increases, therefore exothermic. And that is like such a crucial part. I think most students, including myself, a lot of the time miss out. But what I've made this mistake a lot of times, so I've learned from it. And hopefully, inshallah, I don't make that same mistake ever again. 3.5, a mixture of isomeric alkenes produced from pentyl 2 dehydrated, present concentrated, hot concentrated ferric acid. I saw that part, dehydrated. I'm thinking elimination. Year 1 mechanism, elimination. So I've got pentan 2-ol, the oxygen, the hydrogen, lone pair of electrons, oxygen bonds to H plus. Then middle of C, oxygen goes to this oxygen which is positively charged. Then you've got a carbocation here, and because I know I want to form pent-1ene, it's not going to be like curly arrow this way, which I could do, right? No, but that'll form pent-2ene, and that will move on to here because it says it also forms, and then you can identify that you can only have pent-1ene and pent-2ene. But because I want pent-1ene, so therefore from the middle of CH to this carbon-carbon bond to form pent-1ene. Name the less polar stereoisomer formed. I know it's going to be pent-2-ene, but is it going to be E or Z? It's going to be E-pent-2ene. And explain how stereoisomerism arises. Carbon-carbon bond cannot rotate, and each carbon in the double bond has two different groups attached. Carbon-carbon bond cannot rotate, or lack of rotation of carbon-carbon double bond. Each carbon in the double bond has 2 different groups attached. B could contain this much of A, this much of B, this much of C. Equilibrium mixture contain this much. Calculate moles of this and this and this. Really nice 5 marks, in my opinion. Perfect example of using the ICE method. If you just use the ICE method, exactly what you need to do. So I, additional moles, C, change of moles, E, equilibrium moles, A, B, C, D. 2 reactants and the 2 products. And I know, then I'm going to use moles of concentration volume, find out the moles of A, find out moles of B, well I've already given, moles of C. And I know equilibrium mixture contains this much moles of A. So I've got the initial moles, and I've got also the equilibrium moles. So how do I find what's the change? Well, it's going to be 6.4 times by 10 to the power minus 3 minus 3.9 times by 10 to the power minus 3. So therefore I'm subtracting 2.5 times by 10 to the power minus 3. And that's a 2 molar ratio. So in this case, I'm also going to subtract, but I'm not going to subtract 2.5 times by 10 to the power minus 3. I'm going to subtract 1.25 times by 10 to the power minus 3. I'm going to divide by 2. Then on the right hand side, if I'm subtracting on this side for the reactants, I'm going to add for the products, right? So C, 2.8 times by 10 to the power minus 2. For D, you're definitely going to add 1.25 times by 10 to the power minus 3. And for C, do I add it or not? Minus 2. 5 times by minus 3. Yeah, you add 3.75 times by 10 minus 3. Subtract one side, add one side. You get the moles, and make sure you give it to 2 or 3 significant figures. Give the expression for the Kc for the equilibrium states units. Kc square brackets, products of reactants. Got C and D. C 3 moles, so it's going to be cubed. A 2 moles, so it's going to be squared. The units, moles per dm minus cubed to power 4 over moles per dm minus cubed 3, 2 and 1. So that cancels out, it's going to be moles per dm minus cubed. Different equilibrium mixture of these 4 compounds contain this much. Calculate concentration A. So you just rearrange the equation, get A, square root of that, substitute values in, show the clear substitution, and you get 0.170. That's what I got, but the answer is 0.17. Justify the statement that adding more water equal to mixture with lower the amount of A in the mixture. Adding more water, so all the concentrations will fall. Equilibrium therefore will shift to side with more moles, therefore the right hand side to oppose the decrease in concentration. Question 5. I will go through that in another video. It's a lot of Arrhenius equation, graph stuff, so yeah. But to be honest, it doesn't look too bad, but I'll go through it in a different video. Question 6. Explain bonding in the shape of the benzene molecule compared stability with the hypothetical cyclohexane 135-triene molecule. You just memorize these 3 stages. You should be good for benzene, to be honest. So stage 1 bonding, each carbon has 3 covalent bonds, spare electrons in p orbital, spare electrons in p orbital, developed to form a pi cloud. Delocalization. Stage 2 shape, planar, hexagon / 6 carbon ring with 120 degrees bond angle. Also the carbon-carbon bonds are equal in length. Stage 3, the stability. Expected enthalpy of hydrogenation cyclohexatriene is minus 360 kilojoules mole per minus 1. The actual enthalpy of hydrogenation of benzene is less exothermic by 152 kilojoules mole per minus 1. And less exothermic by 152 kilojoules mole per minus 1, as benzene is more stable. Just copy and paste out whenever you get a benzene question, the bonding and shape of it. Suggest a value for the enthalpy of hydrogenation cyclohexane 1,3-diene and justify your value. It's minus 230 because the double bonds are separated by one single bond / alternating. Let's see there. And therefore allows for some delocalization / overlap of p orbitals. Given the equation for reaction of this with AlCl3 to form electrophile, so CH3CH2Cl plus AlCl3 to form, I'm going to form carbocation, CH3, CH2, C double bond O, carbon positive charge plus AlCl4 minus. Mechanism, so from ring of delocalization to the carbon positive charge, and then you get this, middle of the hydrogen to here, partial horseshoe ring this way, this direction, positive charge there, and there you go. Give the IUPAC name of the alcohol. So methane, ethane, propane. So I've got 3 carbons here. I've also got phenyl group. So it's going to be 1-phenyl propan-1-O. Reason being is because I'm going to start from this carbon, right? So 1-phenyl and then propan, but on this carbon that's where the OH group is, so propan-1-O. Reagent for this reaction. So organic product in question 7.1. Organic product in question 7.1 form to that. So yeah, lithium aluminium hydride or sodium borohydride. Nucleophilic addition. Alcohol reacts with ethanol chloride to form an ester. Misty fumes / steamy fumes. Yeah, misty fumes let off. Name of mechanism, nucleophilic addition elimination. And the structure of the ester, what I would do is put my hand up in the exam, ask for a piece of paper, just go through the mechanism really quick, just literally, obviously depends on how confident you are with the mechanism, but you do need to be really confident with them, and then just go through it really quick. Probably take you like maybe 1-2 minutes and you get that final mark. Explain how these hydrogen bonds form. Well, electron deficient hydrogen attracts a lone pair on the oxygen. That's really it. Electron deficient hydrogen attracts a lone pair on oxygen. Complete structure had the bond that formed between cytosine 2 cytosine molecules. Those can be sulfur-sulfur bond or disulfide bonds. So CH2S, S, and your CH2 there. Tertiary structure. So structure of zitto ion of dipeptide formed by alanine and serine. So first things first, you draw them together and then realize dipeptide, so you bring them together. And here you got your link. And then realize zitto ion, so I'm going to have positive charge here, and I'm going to lose a hydrogen to negative charge here. Complete table 4 to show the correct sequence of bases in the complementary strand represented by numbers 1 to 5. TGCAG, TGCAG. 13 hydrogen bonds. Total number of hydrogen bonds. Complete structure to show, show how The nucleotide contains base A, so base A, but letter A, there. Incomplete 2-deoxyribose molecule, and then P double bond O minus. Give the letter of each compound a correct box, C, B, and A. Use your periodic table to do this. Draw a skeletal form with 3 secondary amines. So you've got here, N is in the middle, or here where N is in the first one, or here where N is on the first one, and you've got 2 and dashes like that. Justify statements better to prepare primary amines for nitriles rather than halogen alkanes. Well, with nitriles, there's no further reaction, therefore single product / higher atom economy. Drug structure primary amine 4 compounds that cannot be formed from nitrile, there, dash, NH2, H, there. Give the equation for reaction that occurs. So propyl amine, methyl, ethyl propyl, NH2 plus H2O, reversible reaction to form this, plus OH minus. Green turns blue. Nitrobenzene, benzene ring with NO2 group attached plus 6 H's, arrow, benzene ring with NH2 group attached plus 2H2O. C6H5NH2 is present as ionic salt. Given number of peaks, 13C NMR spectrum was isomer 1. That counts as 1. That's 2. That's 3, and then that will be 4 peaks. Then explain the splitting pattern of the peak for the hydrogen stable A in its 1H NMR spectrums. I'm going to use N+1 rule. Therefore, the number of hydrogens on the adjacent carbon 2 + 1 is 3 triplet. So here, that's a nitrogen, so it can't be that. Here, 2 hydrogens on my adjacent carbon, so I'm going to add 1. Therefore, it's going to be 3, so it's going to be a triplet. Yeah, so 2 hydrogens on adjacent carbon. Drug structure of the isomer C6H16N2 used to make nylon 6,6. There you go. H2N here and your NH2 here. Just testing how well you know your polymer topic and how to make all these stuff. And this one I have skipped. I'm not sure how to do these ones.